Hello everyone, welcome and good evening, or good afternoon, good morning, wherever you are in the world. That's a nice thing about doing online meetups. People can join from everywhere. So we're back for the second week. Hopefully you enjoyed the last week's sessions, and this week we have another really cool guest talking about some pretty awesome topics, event-driven computing on Kubernetes. So it's ticking all the buzzwords. So really happy to have Jakob here on the show. Jakob is a Microsoft MVP. I met him at a conference last year, and well, we were discussing this topic, and I asked him to come on the show. So really glad to have him here. So Jakob, could you introduce yourself?
Sure, it's great to be here. So again, my name is Jakob Ehn. I'm living in Stockholm, Sweden, where it's kind of dark right now. So I'm a developer by heart, been developing code for 20, 30 years or so. Currently I'm focusing on cloud architecture, DevOps at a company called Active Solution here in Sweden. And I'm an Azure MVP, and I typically spend a lot of time preparing sessions, talking at conferences and meetups and so on. So it's good to be here in the beginning of the Azure Community Live meetup. It's a great initiative.
Yeah, thanks. So, well, let's just get to the content. Let's get started with your session. Yeah, for questions, people can just ask them on the chat. I will check them and pass them on to Jakob so he can focus on his slides.
Excellent. So you can see my screen?
Yep.
All right, let's get started. And there's probably going to be some fitting spot for doing questions. I'm going to talk mainly about two different topics here. So I'm going to break for questions, but keep them coming, and I'll answer them when Gert gives me the chance. So the topic for tonight is event-driven computing with Kubernetes. So I don't have to introduce myself again, since I just did that. So I'm going to go straight into the topic here. And so let me just start with talking a little bit what about kind of events I'm talking about here. So one typical event that will happen in your application is maybe that your service bus, somebody sends a message to your service bus. But other types of events that happens in the ecosystem of your applications is somebody does a push to GitHub. A new version of a container image is pushed to a container registry. Someone approves a pull request, and so on and so on. And all these events typically require or trigger some kind of action. Some of them maybe already are automated. Some of them might be manual today. But typically you want to implement them in some kind of automated fashion. So just to list some possible examples of what could be the outcome of such an event. So maybe you want to trigger a build if some change was being made. Maybe you want to create or tear down some environments, or maybe you want to do a security scan if somebody pushes a new container image. Maybe you want to scale up or down the deployment. Perhaps if a lot of messages coming into your service bus, perhaps you want to scale up your deployment to handle those messages. And kind of the idea of this session here is how can you handle and implement these workflows using Kubernetes as a platform.
Could you pause for a minute? I think I broke the audio. Yeah. Oh, Huh? I did that, right? No. Okay. One moment. Can you hear? It should be Skype. Audio only. I'll just do this. Okay, I think we can continue.
So you can hear me now?
Oh wait, when I change something I should transition as well. Yes, start talking, I'll check it.
All right, the wonders of online meetups. So let's get better. So I'll continue.
Yeah.
So Brigade, it's an open source project developed by the same people who built Helm and Draft. It's the people from the Days company that were acquired by Microsoft a couple of years ago. And I'm going to walk through the features here, and then I'm going to do a few demos on how you can use Brigade to implement various workflows. So the main functionality around Brigade is being able to chaining together containers to create various workflows. This could be simple workflows, maybe doing one tasks, or this could be complex workflows, running multiple tasks, either serially or in parallel. And the idea here is to be able to use the vast ecosystem around Docker and containers, so you don't have to rebuild all this functionality together yourself. So instead, just wire them together, handling different events and calling into the different containers of your choice. Brigade runs inside your existing Kubernetes cluster. It doesn't require anything in particular. You don't have to install it. You can run this on any cloud Kubernetes or on-premise. And Brigade uses JavaScript for creating these pipelines. So the idea here is that you'll write a Brigade script in JavaScript, and in that script you will create various jobs which will then run as containers in your cluster. And using JavaScript is actually pretty powerful instead of using some DSL like YAML, because now you have a full programming languages with all the constructs and the power that comes with it. So if you don't like JavaScript, that potentially is a problem for you. But JavaScript also has a very rich ecosystem, and it's a very powerful language. Brigade also integrates with various event providers. So typically, you will kick off your workflows when some kind of event happens. So again, if somebody makes a push to GitHub, or perhaps an image is pushed to a container registry, this will trigger some kind of event, and the idea is that Brigade will then be called from this event provider. So Brigade comes with some out-of-the-box event providers, and you can install additional ones. And then, of course, you can write custom ones if you want to extend on this. But you can also handle really any kind of event, any kind of JSON document, and use that in your workflow. And I will show you later on how that looks like. Brigade also support cloud events. So you may not have heard about cloud events, but this is a specification for describing event data in a common way, because a lot of systems, basically all the systems and all the cloud providers, have their own kind of proprietary event messaging formats. And the idea around cloud events is that if we can try to standardize on a common format, it will make it, and then have all these systems to produce messages following this format. It will be a lot easier for all types of integrations to integrate various systems without having to map between various formats. So Brigade currently supports an earlier version of Cloud Events. Cloud Events just reached 1.0 recently. Brigade is just now working on supporting 1.0. So let's take a look at the architecture on Brigade. So Brigade contains what's called a gateway, and the gateway is what will receive some kind of trigger from the outside world. For example, a push event from GitHub. That will come into the gateway. The gateway will look up a project. So for every type of workflow that you want to implement in Brigade, you will create a project, and the project contains various metadata like names and so on. It also knows where your Brigade script is located, If it's located together with the project, it could also be located in a separate source code repository, maybe together with the rest of your application code. Once the project is loaded, the gateway will then create a Brigade event. And depending on what kind of trigger, it will create various events here. So for example, if we're talking about the GitHub gateway, in the case of a push being done, the GitHub gateway will then create a push event. And then Brigade will kick off a build. And the build will run multiple jobs here. And each job will run inside a container. And the container of choice is the one that you specified in your Brigade pipeline, in your JavaScript code. So again, here you can run multiple jobs in sequence. You can scale out running them in parallel. You can wait for them. You have a lot of options here. And also, since you're using JavaScript, you can use all that, the power that comes with it in how you want to implement this workflow. So this is an example of a Brigade script, a very simple one. And you can see that we're requiring the Brigadier script. So that's where the Brigade functionality is located. And then you will listen to one or more events, because that's how your script will be triggered. So in this case, I'm listening to an event called the exec event. Inside that event handler, I'm creating a job. So a job has a name. In this case, I'm calling it just to say hello. And then I'm specifying the container of choice, the container image. In this case, I'm just using the Alpine Docker image and in a specific version. And this means that then Brigade will kick off a pod in your Kubernetes cluster with that container image. And inside that image, I will then run a series of tasks. In this case, I'm just doing 2 tasks. I'm echoing hello, and then I'm echoing the world. So it's pretty simple. But those commands will now run inside that container. And finally, I'm doing job run at the bottom. So this is where I'm actually running the job. And here I could also potentially run multiple jobs and so on. So, but this is the basic example here of how a Brigade script looks like. So talking about Brigade events, the Brigade count. So you have these custom gateways, which could be GitHub, Azure Container Registry, and so on. But then you have the generic gateway, which will basically accept any kind of message as long as it's a valid JSON document. And there's 2 types of endpoints that the generic gateway will listen to. The first one is the simple events. And it will accept requests on this format, where the project is the ID of the project, and the secret is how you actually will kind of authenticate towards Brigade, making sure that you have the secret so you're allowed to call into that gateway. So if you're using this, you can basically build any kind of integration. As long as you're sending a JSON document on this format, it will be picked up by the gateway. The other endpoint is the cloud events endpoint that I talked about before. And you can see that the format here says V02. That means that Brigade currently supports the version 0.2 of the cloud events. But again, they're working on supporting the 1.0 format, and I think that should be there pretty soon. But then you have a custom gateway. So again, if you're using GitHub, Container Registry, or a gateway that you're building yourself, then it's really up to the gateway to determine what kind of messages or the format of the request, what it should look like. So in this case, it will look differently depending on which kind of custom gateway that I'm using. So, and again, either way, if it's a generic gateway or if it's a custom gateway, the what's going to happen afterwards that it's the same. It's going to look at the project depending on the project ID. Then it's going to create the event and kick off a build inside Kubernetes. So I'm going to do a few demos on Brigade, and after that I can open up for questions before I move on to KEDA. So I think that will be a good place to start. And the demos that I'm doing is, first I'm just going to show you how to get started with the Brigade, how you can create and run the Brigade pipelines. Then I'm going to show you how can you trigger a pipeline when you're doing a push to GitHub. Then I'm going to show you how you can integrate with the cloud events. So Azure already supports cloud events. So for example, the Event Hub or supports cloud events. So it makes it possible for you to send events on the cloud events format when something happens, for example, in your storage account. And I'm going to show you a demo on that. And the last demo is from a customer case, actually. where we're using Brigade to really complement a pull request workflow. And so I'm going to show you how that works from a kind of anonymized customer case. So I'm going to switch over to the demos. And I'm going to show you a few links at the end of the presentation. All this code is available at GitHub, so you can play around with it later on. And just contact me if you have questions around it. So to start with, I'm going to show you how you can get started with Brigade. And installing Brigade into your cluster is really simple. If you're using Helm, it's basically just 2 lines. You can also install it in a few other ways, but I'll say that this is the easiest one. In this case, I have already installed Brigade into my cluster. And so let's take a look at my deployments. Sorry. And just as a note, when I'm typing K, this is actually an alias that I'm having for kube control or kubectl, the command, the CLI for Kubernetes. So it just saves me a few clicks every time. So I'm looking at the existing deployments in my cluster here. And you can see there's multiple deployments here that are related to Brigade. We have the API and the controller. And the controller is that's kind of the brain of Brigade that will coordinate the work. Then we have a few gateways. We have the generic gateway that I talked about that can handle really any kind of event. And then we have 2 specific ones, the GitHub gateway and also the event grid gateway for Azure events. Finally, we have something called Brigade Custody, and that's actually a UI dashboard that we can use to visualize what's going on in Brigade. And I'm going to show you the dashboard, but also you can also actually use the CLI to see what's going on in your Brigade deployment. So Brigade also comes with a CLI of itself. It's called Brig, and you'll install it. And using that CLI, you can really do anything with Brigade. So you can create stuff, you can monitor stuff, you can delete stuff, and so on. So for example, I can see my existing projects here. So I do a Brig project list. And so you can see I already have 3 different projects here that I'm going to demo. But I'm going to start with creating a new one so you can see how this works, because it might be a bit mysterious in the beginning. So I'm going to create a new project here, and I'm going to walk you through it. So I'm going to step into my first demo folder here. Before I create this project, I'm going to show you the Brigade file that I'm going to use here. So this is almost the same file that I showed you on the slides. The difference is that it has 2 jobs. So it's listening to the exec event, and then it does the hello world job on the Alpine image, where it echoes out hello world. And then I'm having a goodbye job, and then it's going to echo goodbye world instead. And at the end, I'm running these 2 jobs. So I'm using here the run each construct, which will let me pass into an array of jobs here. And doing this will actually run these 2 things sequentially. If I wanted to, I could use the run all, and that will actually run my jobs in parallel. So just to, and then wait for these jobs to finish. But now I'm going to run them sequentially. So the idea is now I'm going to create a project and deploy the script, and I'm going to show you how you can run it to see how this works. So let's go back here, and then I'm going to do a Brig project create. And this is actually a wizard that you can walk through that makes it really easy to create it. So the first question here is going to ask you if this project a version control project or not. So depending on your case, you might want to have these Brigade scripts together with your application. It might make a lot of sense. Sometimes you want to have it somewhere else. So you could either point now to a version control repository, so for example a GitHub repo, or you can store that script together with the Brigade project. So in this case, I'm going to store it together with the project. The next demo, I'm going to show you what it looks like when it's stored over at GitHub. So I'm selecting the no VCS here. So then I'm going to give it a name. So I'm just going to call it the Jakob/demo. You can call it really whatever you want here. It's going to add me it's going to ask me for if I want to add some secrets, and the secrets is these kind of secrets is if you need something in your workflow, in your logic, perhaps to authenticate to some external systems or something. In this case, I don't need anything. In the later demo, I'm going to integrate with Slack. So in that case, I'm using the webhook URL as a secret. But I'm going to say no here. But then it's going to ask me for the secret for the generic gateway. And this is something that I will need if I want to be able to actually call this or trigger this workflow from the outside. I showed you the format before. So I need to enter the secret here. So I'm just going to type super secret. And this is a value that you will need to pass when you call this this Brigade project from the outside. And finally, I'm going to specify the name of my Brigade script, which is called Brigade.js. And that's it. That's like the basic project here. So let's do a Brig project list. And now you can see that I have 4 projects now. So this is the Jakob demo one. It has an ID. It also has a URL or repo URL over here. And you can see that this is really a kind of a dummy URL because I didn't specify that this was a version controlled project. In my second demo around GitHub, here you can actually see that it points to a GitHub repo on my GitHub account. So, and let's take a look at the project. So we can do a Brig project get, and I do type Jakob demo. So now it shows me the content, and these projects are actually stored inside Kubernetes as secrets currently. That's how they selected to store this information. So just to take a quick look on what's the content of the projects. So you have the name and some labels and so on. Here you can actually see the script. So you can see the default script property here, and inside here is actually you can see that the JavaScript code that I showed you. So, and this is because I selected that this wasn't the version controlled project. And you can also see the secret over here. Okay, so we have this project. So let's run it. And so the typical case here would be to trigger it from the outside using some kind of webhook calling into my Brigade deployment. But I can also trigger events locally by using Brig run. And when I do Brig run, it's going to trigger the exec event, which is the one that I'm actually listening to. So I'm going to do Brig run Jakob demo. And let's see what happens. Let's start it. So you can see the output here now. That let's just quickly walk through it. There's some detailed information here. But what's going on at an overview here is that it's going to it's going to execute my script, and when I'm running a job from my Brigade script pipeline, it's going to create a pod in Kubernetes. So you can see the first one is to say hello. So you can see the name there, and then it's appending an ID afterwards. So it's creating the pod, and then it's running the pod. And as soon as that pod has finished successfully, it's going to schedule the next pod, which is a say goodbye one. So you can see now that it's running this 2 pods sequentially, and then the job is done. I can again use the CLI here. I can ask Brig to show me the builds. So you can see now that I have one build that just succeeded, and I can actually go and do a Brig build get and just select the ID here. And that will show me the output that you saw here. But really, what you're mostly interested about is what's the output of the containers. And I could do, I could look at the actual pods here. If I do a kubectl get pod, we can see at the bottom here the 2 pods, the say goodbye and the say hello. They completed 81 seconds ago, and I could do a get logs here, and actually see the output here. So now you can see actually the output from this pod, which was hello world. Now this is nice, but there's also 2 ways of using a UI with a little bit more functionality to see what's going on and for troubleshooting stuff. So the first one is the UI, the cached dashboard, and I can launch it much like you would launch the Kubernetes dashboard. I can do type Brig dashboard, and that's going to proxy me into a UI here that looks like this. So here again, you can see the various projects, and you can see that the Jakob demo one has actually been executed. That's why it's green. So we can drill down into that one. Here we can see that we have one build in here. It was triggered by the Brigade CLI in this case. And if we drill down into this one, we can see the output of the Brigade pipeline. But we can also see each job down here. And we can even go down in here and here see the output of each job here. So the same thing that I showed you from the command line or using kubectl, you can see here in using this UI. So this is pretty nice. There's also another UI that you can install if you want to. It's a CLI UI, if you want to call it that. So it's called Brigade Term for Brigade Terminal. And if I'm running that one, you can actually see inside your command line interface, you can see basically the same thing that the UI, the dashboard showed you. But you can instead use just your command line to navigate around it. So again, I can see the 4 projects I'm having. I can see that the Jakob demo was executed 3 minutes ago. And now I can drill down here, see the exec event. And now see the 2 jobs. And at the top here, you can even see a timeline that says that first this pipeline ran say hello, and then it ran the say goodbye one. And again, I can drill down into one of these jobs and view the output here, the goodbye world. So two different ways of looking at your Brigade projects and builds for troubleshooting and to see what's going on here. So that's how you can trigger and test your pipeline from locally. But a more realistic way now would be to send an event into your Brigade deployment from the outside. So this cluster is now is running. It's deployed into Azure Community Service. That's where the Brigade and the pods are running. And what I can do now is I can use this the message format that I showed you, which is a simple events one. So I'm going to use Postman here and see how you can post a message into my pipeline. And I prepared the URL here, so you can see that the first part here is called brigadedemo.en.nu. This is how I set up the custom domain and the ingress. That will of course look different depending on how you set up your cluster. So you can kind of you don't really need to pay much attention to that thing. So the interesting part is the next one. So this is the simple events /v1. So if you remember from the slides, this is how you would call into the generic gateway of Brigade. And then the format requires you to pass in the product ID and the secret. So let's go back to here and do a Brig project list again. So we need the ID here of the project. So this is this one. So I'm just going to copy it here and replace product here with the ID. And then the secret, that's the one that I entered when I created this project, if you remember. And I called it super secret. So this URL now should post a message into the generic gateway. Down here, I'm just specifying just a sample JSON document. I'm not really using it in this case. You just need to send some kind of valid JSON document into that gateway. So let's do a send here. And you can see that the request was successfully, and the response from Brigade is just the status that says success build created. So let's go back to here, and actually we could look at the dashboard again. Let's do a Brig dashboard. And let's go back into the demo. So now you can see that a second build here was kicked off. In this case, you can see the first time we used the Brigade CLI to trigger it, but in this case, it was a generic webhook, and you can see that it was a simple event that was triggered here. And it ran for a few seconds, and again, we can drill down into here. In this case, I'm just echoing out what I passed in here. So this is how you would set up integration from kind of the outside world. And if you're using a generic gateway, you just need to follow that format of the simple events, supplying the product ID and the secret, and then you can just send any kind of event in here, and then you will handle this inside your Brigade script. So really easy to get started here and to start working on your integrations like this. And again, the power really comes from the fact that it's super easy now to just use existing container images. It could either be container images from the public, from the Docker Hub, for example, or it could be custom container images from that you're building. And then you can just chain them together here using JavaScript. So this was the basic example. Let's go into the next demo, which I'm going to show you is to see how we can integrate this with GitHub. And let's take a look at the Brigade script here. So in this case, I'm doing a little bit more here than just doing echo. I'm actually creating a super simple CI system here. So I'm listening here on the push event. So this will be triggered then when I set this up from GitHub, when somebody does a push to the GitHub repo. Then I'm creating 4 different jobs here, and at the end I'm running these jobs sequentially. And in each step, the first 3 steps here, I'm using the .NET Core base image from Docker Hub, which makes it possible for me, in this case, to do a build. The second step will do a test, and the last one will do a publish. So I'm just using the ready-made images, and I can use the .NET tooling that are available on those images. So, to kind of simulate a very simple CI/CD system. And I just want to point out that, if you probably you're already having a CI/CD system like Azure DevOps, for example, and I'm not really suggesting that you would replace that with Brigade. But this is just one possible thing you could do. And it's actually for small teams that maybe don't already have a CI/CD system, but they are running on Kubernetes. This doesn't require any extra infrastructure or any other systems. You can actually implement a simple CI/CD system just using Brigade. And the last step of this pipeline is I'm using Slack, using a custom image that makes it very easy to post messages to Slack. So the idea is that when the compile, test, and publish is done, it's going to send the message to a Slack channel. And let's take a look how this project is already created. Again, if we do a big project list, this is it's called the Brigade app. So let's take a look at what this looks like. So the main difference here compared to the one that we created first is that the source code, the Brigade script, is not located with the projects. It's located over at the GitHub repo. So you can see the clone URL here is pointing to a GitHub repo. So in fact, when this pipeline is kicked off, Brigade will actually automatically clone this repository for you. So the source code is available. And that's what makes it possible for my jobs here to just the source will be available, in this case, from the GitHub repo. It will already be downloaded into that image. Actually, it's going to be mounted into that image using a volume mapping. But I don't need to do that myself. That's being done for me by Brigade. So let's take a look at the GitHub repo here. So this is just a super simple sample application, just a console application. But let's see how I set the webhook up. So kind of how do I trigger events from this one hitting my Brigade project? So if you go to your GitHub repo over at settings, you can configure webhooks. This is one way of doing it. You can also use GitHub apps, which is a more fully functional way of, especially around authentication. But the webhooks is a simple way of doing this. And you can see that I'm set this up before. I'm going to do edits. So you can see a little bit more detail here. And so the payload URL here is now, again, I'm pointing to the Brigade demo.en.nu, which is my cluster. And then I'm using the /events/GitHub. So this is the format that the GitHub gateway in Brigade listens to. That's the endpoint you need to hit. Then I've specified the secret here, so that will be passed on, and make it possible to. So again, you can't see the value here, but here I typed the secret that I supplied when I created that Brigade project. So let's test this by doing a change. So let's go to just the program CS here, and we're going to edit the file. Let's just add a comment so it doesn't break anything. Hello, Azure Community. It's spelled. And let's just commit this one. So this one should now trigger this webhook, and that webhook will then call into the Brigade pipeline. So let's quickly go back here and let's run the Brigade terminal. And you can see now that this project is already running. It's kicked off a build. Let's go into that build. So you can see that the event type in this case is the push event. And if I go into here, I will now see this the jobs that I showed you before, the 4 different jobs. Now it's already done the compile job, the first step, and now it's running the test job here. If I drill down into the compile, here I can see the output from that those commands that I ran inside the container, which in this case were .NET build. So you can see that this kind of mimics a very simple CI/CD system. And it's doing a compile, it's doing test, it's doing publish, and finally, as you can see here on the timeline, it's ran Slack notify. And if that thing worked, I also should see a message being posted here. So you can see that this message just came in here, just says that the sample app was built and tested successfully. So again, super simple to wire these things together without having any extra infrastructure being set up or anything. The only thing I needed to do was to write the scripts. I use existing Docker images like the .NET Core SDK image and this Slack notify image, and then I'm just wiring this together using JavaScript. So really, really simple to set this up, but very, very powerful at the same time. So the next demo is a little demo around how you can integrate using cloud events. So to show you this, I have configured an Azure storage account on my Azure subscription to send a cloud event, and that will be handled then by my Brigade project. So let's take a look at this Brigade file here for the cloud events. So you can see that I'm listening to 2 different events here, the Microsoft Storage blob created event and the blob deleted event. So you get the idea here is that if you create a blob, so basically if you're uploading a file to your storage account, that will then trigger an event that will be called in this pipeline. And then I'm just parsing the payload that comes in to see which file it was. And I'm just, for demo purpose, I'm just typing out the URL to make sure that I could. So, but here I could really do anything with that file that was just uploaded. So this is the pipeline part of it. Let's take a look at my Azure subscription to see how I set this up here. So this is a storage account in my Azure subscription. Now, if you go to the Events tab here, this is where you can set up various event subscriptions. And I'm just going to show you how you can do this. If you hit the new event subscription, here it defaults to the event grid schema. But here you can also see that you can select the cloud event schema version 1.0. So here you can specify when something happens, you can send a message out to some receiver on this standardized format that in time a lot of various systems will be able to process without you needing to map anything. Because the event grid schema, that's proprietary to Microsoft and to Azure. And not a lot of systems outside Azure will know the format here. But I already set this event subscription up. You can see at the bottom here, I have an event subscription called Send Event. I'm just going to click to show you what it looks like. It's a bit small here, so I'm going to zoom in here. So here you can see that URL. And again, it's the brigade demo.en.nu from before. And here you can see I'm using the cloud events 0.1. And then I having the project ID and the my secret, which is the secret I used for this Brigade project. So you see it uses the 0.1. It's not the 1.0 yet, since Brigade currently doesn't support 1.0. So let's try this out. So I'm going to go to my blob here, the blob container, and I'm going to upload a file here. I've done it a few times before. Let's just upload an image. So when I'm uploading this blob, it will then should trigger the blob created event. So the file is uploaded. Let's go back to this one. Let's run Brigade term. And so this was super fast. It's already done. So you can see that the cloud events was triggered 20 seconds ago. And you can see that the type here is Microsoft Storage blob created. So let's go into this one. And you can see that the job, I would call it the process storage file. And inside there, you can see I'm just typing out the URL here. So this is the URL from that file that I just uploaded. So you can just imagine here that I could do basically anything with that file. I could download it, I could process it, maybe do some image transformation, upload it to another storage account, something like that. And using the cloud events makes it super easy, because then I can just use the cloud events SDKs, which will then understand this format and make it a lot simpler for me to write these integrations without having to come up with some proprietary format. All right, so that was cloud events, and the final demo for Brigade will be, as I said before, from a customer case where we use Brigade, and I just basically stripped it down and anonymized it a bit, but it's the same principle. So in this case, we are doing a Kubernetes deployment. And we have a pull request workflow set up so that every time we create a pull request, we will spin up a new namespace, a new environment in Kubernetes, and deploy the application to that namespace. And that's really powerful, because we can then have automated tests. We can have stakeholders looking at that environment and work on it. And once it's done, we'll complete the pull request and merge it into master, and then deploy it into the master environment. So the problem that we try to solve, that's quite easy to set up using Azure DevOps to actually trigger a deployment using a pull request like that. The problem is that we wanted to make sure that these environments were deleted once the pull request was completed. And there was no really good way to do this by just using Azure DevOps. We wanted to make sure that no matter for how long this environment was up there, we want to make sure that when that pull request is completed and the branch is deleted, the corresponding namespace and that deployment in Kubernetes should also be deleted. So this turned out to be a really good case for Brigade. So this Brigade script is a little bit more involved, and I'm not going to go into super much detail here, because that's not really the point. But this is what we're actually doing. You can see that we're using two different container images. The first one is for using Helm commands, and the other one is for running kubectl commands. And the gist of this script is that it checks, because it's going to be triggered every time we do a change to the pull request. So we're just going to make sure that this is a pull request on a particular path in our source repository. And once that pull request is completed, we're going to run these two jobs, where we're first using Helm to delete the namespace, the deployment. But unfortunately with Helm, you can't delete the namespace itself. So we need to run one more command, which is the other job, so the kubectl delete namespace. And you can see that we're using this PRID here. So that's the information that will be coming in to the event here. So here we're using the generic gateway. So we're listening to the simple event here. And then we get the event information here that we can parse and then just extract the information, such as the pull request ID here. So let's see how we set this up in Azure DevOps. So I already have a pull request here that I'm going to finish real soon. But before I'm doing that, let's just see how we set up the integration here. So we're using what's called service hooks. So this is basically the same thing that we saw in the GitHub. And here it's called service hooks. And let's take a look at this one. So in this case, we're using the pull request updated event. So anytime a pull request is updated, we're telling Azure DevOps here to call into a webhook here. And if we type next here, again, we can see the URL here. You can zoom up a bit so you can see. So by now you should be familiar with the format here. We're using the simple events /v1. Then we have the product ID. And at the end, we will have the my secret, in this case, the secret for this particular project. So very much the same way that we did with GitHub. And so before I complete this pull request, let's just go back here and do. So I'm going to look at the existing deployments here. So I'm going to use run helm ls. So it's a bit wide here. So you can see actually that I'm having the one namespace here, one deployment called the sample web app -106. So this was then the deployment that was made when this pull request was created. So 106 in this case, that's the ID of this pull request. You can actually, you can see it's using this URL, but that's the ID of this pull request. So, when the pull request was created, we created the namespace, we deployed it into that. But now, when it's time to complete the pull request, we want to make sure that this namespace and everything in it is deleted properly. So let's go inside this pull request. Oh, actually, this is the pull request. Here you can see the ID that I was talking about, the 106 here. So the build already succeeded, so I'm going to approve, and I'm going to complete. So now when I'm doing complete here, that should then trigger the service hook that I showed you right before this. So let's just complete the merge, and let's quickly go back here, and maybe this time we can do Brig dashboard. And so you can see that it's already it's already done actually. So it's super fast. So this project was called Jakob/PR. Let's go in here. It's actually still running here. So let's see what's going on here. It's running here, and this is the output from the job. And you can see down here that it's finished the Helm delete release job. We can view the output from here, so you can see here that it's now it's running inside this Kubernetes -helm container image, and it's running the Helm delete command, and the output is that the release sample web app 106 was deleted. That's the first step. Again, to actually delete the namespace, we need to use kubectl. So that's the second part of this job, or the second job really, where we're running kubectl delete release, and this is the output from that job. So it says that now the namespace as well is deleted. And if we go back here and we rerun the Helm ls, we should see now that the sample web app -106 deployment namespace is now gone. So the pull request was completed, and we deleted everything as expected. So this was actually a perfect way of using Brigade. We're kind of complementing a workflow that wasn't easy to do in Azure DevOps. We already had Kubernetes as a platform, so we didn't have to invest anything in extra infrastructure or learning another kind of system. We did have to learn Brigade, of course, but it turned out to be a very good solution for this kind of problem. And we see a lot of other potential use for Brigade here, so that's why I'm excited about it, and I'm excited to show you about it. And I'm sure people already are coming up with all sorts of interesting implementations here, using their skills around the container images, around Kubernetes, for implementing this. So that was the demos that I wanted to show you around Brigade. And I don't know if there is some questions right now, Shet. Maybe that's for around Brigade. That would be a good option to do now.
I don't see any questions being asked currently. So
okay.
Just continue. We have some time.
Yeah, that's good. And of course, I'm available on the internet after this session is done. So just contact me if you have more questions around this. And the last slide, I will show you the link to the repository where these samples are located. So let's move on to the second part of the presentation when I'm talking about KEDA. And this is also related to event-driven computing. And KEDA solves one particular problem here very well, and that's around event-driven autoscaling. And that's what the name stands for, Kubernetes event-driven autoscaling. So KEDA is also an open source component. It's from the beginning, it's a joint collaboration between Microsoft and Red Hat. And it's about scaling your deployments in Kubernetes based on events, event data. And so you can scale your deployments to the thousands, depending on how big your cluster is. But another important thing here is you can also scale it down to 0, which is something that you can't do, at least not currently, using the existing auto-scaling functionality in Kubernetes. And I will come back to how this actually works then. KEDA also supports various event sources. So there's a lot of systems out there that can handle events, various types of service buses, message queues, and so on. And a lot of them already supports KEDA, so it makes it very, very easy to integrate with these event sources. And also, KEDA makes it easy to run and scale Azure functions in Kubernetes. And there are some reasons why you would want to do that. So Azure Functions is a great programming platform to really, in a very simple way, implementing functions using triggers, using the integration APIs that are available. And of course, the common way to run those functions are using the standard Azure platform. But you can also run Azure functions in a container. So the Azure function runtime is available as a Docker image. And that makes it possible to run your functions, for example, in a Kubernetes cluster. So that could be, for example, if you need to run your applications on premise. Maybe you need to access some APIs that are internal to your organization. Also, it might make sense. I see a lot of cases where the customers are mainly into Kubernetes, but then they are kind of sprinkling some Azure functions around it to implement some integrations, because it's just so easy to do it in Azure Functions. But it also means that you have a completely different way of building and packaging and deploying those things compared to how you deploy your Kubernetes applications. So by taking those functions and running them in your cluster, you now have one way of packaging in your whole applications, including those functions, which is kind of nice. So if you're familiar with Kubernetes, you probably know that Kubernetes has an autoscaler. It's called the horizontal pod autoscaler, the HPA. And that works in the way that it will look at, if you enable this one, it's going to look at your deployments, and it's going to use metrics such as the CPU and memory consumption to determine if this deployment needs to be scaled. So when you enable the HPA, you tell it to, you're going to pass in some limits to this autoscaler. For example, you can say that if this deployment goes, if this pod goes over 50% CPU, I want you to scale up the number of pods up to a certain number of replicas. And this works really well for those kind of applications that consumes a lot of CPU and so on. But if you're talking about event-based applications, where you're typically are subscribing to a topic on some queue somewhere or a service bus, it's not really the same thing there. If the messages starts piling up on that queue, it doesn't really make your application consume a lot of CPU. It's just going to take longer and longer time for you to process that whole queue, because you're going to, if you have one instance of your pod that consumes the messages on that queue, it's going to just pull one message at a time. And even if you're putting 1,000 messages on that queue, your pod won't run faster. It won't scale because it doesn't consume more CPU. So the HPA in Kubernetes it's not a good fit for event-driven auto-scaling. So this is what KEDA sets out to solve then. So again, KEDA, the open source project, supports a lot of different event sources, like the Azure Event Hub, Kafka, Prometheus, AWS CloudWatch, and so on. And of course, this is fully extensible, and more of these event sources are coming as we speak. So the main parts of KEDA here is the controller, which is kind of the brain of KEDA. And then it also has this concept of scalers. And the job of the scalers is to look at this external source. So for example, a message queue. And depending on how you configure it, it's going to look at typically the number of messages lying in that queue. And then it's going to convert that into metrics that can then be passed into the horizontal pod autoscaler. So it's important to realize that KEDA doesn't replace the HPA in Kubernetes. It hasn't written its own autoscaler. It's actually using that HPA. So what it does is that it can scale up from 0 instances to 1, because that's something that the autoscaler in Kubernetes can't do. And then it's going to feed the autoscaler with the metrics. So it's going to take the information from the event source, convert it into the metrics that the HPA can understand. It's going to pass them into it, and then it's going to scale up. So I'm going to show you this a little bit more detail here, how this works. So let's say you have a Kubernetes cluster, you have a deployment running there with one pod, and then you have a queue somewhere, maybe an Azure service bus or a source queue or something. So, and that pod will now consume messages from that queue. So again, the problem here is that if a lot of messages are coming in on that queue, the autoscaler in Kubernetes won't really be able to scale the number of instances of your pod up, because your pod doesn't really consume enough CPU. So the problem here is that we want to take the fact that we have a lot of messages and get that information into the autoscaler and scale up. So then that's the job for the scaler. So KEDA adds a custom resource definition to Kubernetes called ScaledObjects. And this contains some information so you can configure it, how you want it to scale, and what type of event source it should monitor. So the ScaledObject will then look at the queue in this case, and it's going to take the information that it sees there, in this case the number of messages lying in that queue, and then it's going to feed that information as metrics to the horizontal pod autoscaler. And then the horizontal pod autoscaler will then scale your deployments up. And depending on the queue size and how you configure it, it's going to increase the number of pods, and those pods will now be able to consume messages faster from that queue. And so this is the general idea of KEDA. Here's an example of a ScaledObjects custom resource definition. So this is something that comes when you install KEDA into the cluster. And so the interesting parts here is, first of all, we are referencing the deployment that we want to scale. So the deployment name here is called, I'm referring to a deployment called order processor. So this is a deployment that this is basically my application that consumes messages. Then you have the trigger section, and this section will be different depending on what kind of event source you're using. In this case, I'm using the Azure Service Bus trigger type, and that means that the information below in the metadata section is related to an Azure Service Bus. So I'm specifying the name of the queue to monitor. I'm giving it the connection, so how it actually connects to that service bus. And I'm specifying the queue length of 5 here. And that means that if the number of messages goes above 5, this scaler will then start to trigger auto-scaling. And depending on how much, there is some logic in how it actually converts that number into deployment. And but the idea is that if it goes above 5, it will scale up your deployment, called the order processor. And the last part here are how you can actually configure how the scaling should be done. So you can see that we have a min and max replica count. In this case, I'm saying that we can't really scale infinitely. We don't want to overload the cluster with the pods if we have thousands of messages lying there. So in this case, I'm saying that the max number of replicas is 10. And in this case, I'm actually saying that I also want to have one replica, one pod running here. But I could specify this as 0 as well, and I'm going to do that in the demo later on. Then we have the polling interval. This is how often it will check the service bus queue. And the cooldown period is how long should KEDA wait before scaling down your deployments. And that's something that you might need to play with a bit to see what's a good number here, because you don't want to have it to be too short, because it could be a bit flaky sometimes. So it defaults to 300 seconds, but here I've set it to 30 seconds in this example. So enough talking about this. Let's show some demos on how you can use KEDA to, first of all, scaling deployment. So I'm going to show you a demo of how we can scale deployments where we have an application that consumes messages from an Azure storage queue. And the second part, I'm going to show you how you can take Azure functions and run and scale them using KEDA, using the tooling that comes with around the Azure functions, but also comes with KEDA. So let's go back to the demos. And hang on one second here. So I'm going to switch to another cluster. Let's do to my KEDA cluster instead. So again, installing KEDA, much as Brigade, it's very simple. We can use the Helm commands. So you just start by pulling down the Helm charts from the chart repository for KEDA core, and then you're running Helm install of the KEDA core /KEDA. You can do it in a namespace if you want to, and that's basically it. That will install the KEDA controller and the custom resource definitions and so on, and you're good to go. So I'm going to show you. I already deployed the application here. So let's do let's see what we have here. Let's do a get deployment. So you can see I have two deployments in this cluster. One of them is the order web, and that's a web application that shows the number of messages lying in that queue. So this is also for demo purposes, so making it a bit visual. But the interesting part here is the order processor. So this is the deployment. This is the application that actually consumes the messages. And you can see what's interesting here is that we actually have 0 instances running here. There's no replicas running here. And normally in Kubernetes, that would be a problem, because you can't autoscale this one, because in Kubernetes, or actually looking at the horizontal pod autoscaler, to be able to scale something, it needs to pull metrics from that pod. And if you don't have any instances, you can't autoscale it. So this is where KEDA steps in and will actually be able to first up create one instance, one replica of this deployment when it needs to, and then it's going to autoscale up even more if needed. So this demo is actually based on a sample application made by Tom Kirkov, which is another Azure MVP, and has been working a lot with the team behind KEDA, and so he's been doing a lot of stuff. I added some parts. I added the web application part of this demo. It's over at the GitHub repo. I will show you the link to it later on. So the idea is that I'm going to send a lot of messages to this queue, and we're going to see that it will scale up the processing here. So let's take a look at the web that I have up here. So this web application just shows the number of messages lying in that queue. So it should be 0. So yeah, it doesn't show me anything. So the queue is currently empty now. And I'm going to start pumping messages into that queue. But before I do that, let's take a look at the deployment. And so let's do get deployment order processor and doing a wait here. So now it's going to look at so we can see any changes being done to this deployment. So still we have 0 instances because nothing has happened. There are no messages lying on that queue. So I'm going to kick off an application that will send a lot of messages in here. So I'm going to run the order generator program here. It's going to ask me how many orders do you want to send. So I'm going to send 300 messages to this queue, and then we're going to see that happen. So the idea here is now that once messages start coming in, it's going above 5 messages. KEDA will pick that up, or the scaler for Azure Service Bus will pick that up and see that once it's above 5, it should scale this deployment up to first 1 instance, and then it's going to scale up even more until the number of messages goes below 5 again. So let's run this one. So it's going to start pushing messages here, and we can put this next to each other. So you can see now to the right here that the number of messages in the queue is going up. And so it's around 200 now. And to the left here, you can see now that it's KEDA now has scaled my deployment up to 1 replica. And now it's going to scale up even more. And as you will be able to see soon is that now we have 4 instances running. And so you should be able to see that the number of messages here will start to go down. This page refreshes every 2 seconds, I think. So now you can see that it's being pulled down. Now I'm having 8 replicas. So now I have 8 running instances of this processor that consumes messages. And I think it's going to go all the way up to 15 replicas because we're still way above 5 messages. So now it's scaling up to 15 pods. So 15 instances of this application running on the cluster. And now you should see the number of messages here decreasing pretty fast at the end here. So the order processor simulates doing some work. So it actually does a sleep for 2 seconds just to simulate some work. And yeah, now you can see that the messages is pretty fast going down to 0. And once it's below 5, it's going to wait around 30 seconds because that's how I configured it. And then it's going to actually scale down into 0 instances. And while we're waiting for that, we can actually take a look at the scaled object that I deployed here. So this is the scaled object, same thing that I showed you before on the slide. This is how I configured it. I actually specified 0 here. That's why our deployment didn't have any replicas at all. And the maximum was 15. That's why you saw that it went up to 15 instances. I'm polling every 10 seconds here. So this is a trade-off, how often you want to poll here. And then after 30 seconds, it should cool down and scale down. And you can actually see now that it's scaled down into 0 instances. So this is pretty cool because it means that you can have 0 resources using your cluster when the queue is empty. But as soon as you're getting a lot of messages coming in, maybe something big is happening in your system, you can quickly scale up your deployments using KEDA when you need it. And as soon as those messages are processed and done, you can scale down again. And perhaps you can also scale the whole cluster down. You can, of course, combine this with the cluster Autoscaler in Kubernetes to add or remove more nodes when needed. So pretty powerful stuff. And second and the last demo that I'm going to show you is the way that KEDA works with Azure Functions. So again, Azure Functions is a very popular programming model or a framework or whatever you want to call it, because it makes it really easy to combine, write pieces of functionality that you can call, and it has been possible for quite a while to run Azure Functions in a Docker container. So Microsoft made a Docker image available that contains the whole Azure Function runtime. So that makes it pretty easy to just package it into a container and run it, for example, in Kubernetes. But a big problem here is that if you're just doing that, you don't have any way, you don't have this auto-scaling functionality that you get with Azure Functions, in particular with the consumption plan with Azure Functions. And this is what KEDA brings to the table. It makes it possible to not just run Azure functions in your cluster, but also to scale it from 0 instances if you want to, up to the way as much as you configure it. So I'm going to show you how easy this is to set up by just creating a new Azure function. And let me just. So I'm going to use the Visual Studio Code tooling here to create the function. Because again, it's really simple. So just going to select the folder where I'm going to put it. And I'm going to select the language. So I'm going to use C#. And then I'm going to select how do I want this Azure function to be triggered. So I'm going to select the queue trigger here. And that means that this function will be triggered every time I add something to this queue. I'm just going to keep the default settings. And I already have the queue set up. It's called the KEDA queue. I'm going to show you what it looks like in the Azure portal later on. So I'm just going to give it that name. And I'm just going to select the storage account here. That I'm using, it's called the sample queue function here. So now it has created a function. Let's take a look at it. So this is the source code that is generated, and then you have the host JSON file and everything that is related to building and running Azure functions. So I'm going to add a simple sleep here, just to make it a little bit more realistic. So that's to simulate that some work actually is being done here. So every time a message is received, it's going to log some information, and then it's going to sleep for 1 second. So, if you have used the function tooling, you know that you can just very easily run it locally to try it out by using the func CLI. That's the CLI for Azure Functions. And if you do a func start, it will run the function locally, which is also, of course, something that you want to do. So let's just quickly do that. To show you what it works. Now the function is running, and it's basically waiting now for something to happen on that queue. So let's go to the Azure portal and go to my storage account, where I should have a queue called KEDA queue. And so this queue is now empty, and I can now, just to test the functionality, I can do hello Azure, send a test message here. So hello Azure Community Live, I'm sending it, and that should pretty much almost immediately trigger this down here. You can see now that it logged the message information, and then it slept for 2 seconds. So super simple to create an Azure function and run it, of course. So this is standard Azure function functionality. And of course, now I could package it up and deploy it into an Azure function app as usual. But that's not what we want to do here now. Now we want to package it into a Docker container, deploy it to Kubernetes, and then we want to scale it with KEDA. And we could do all those steps manually, kind of if you want to, but the tooling around KEDA and Azure Function makes it super simple to do this. You almost don't have to do anything to implement this. So it's just really 2 things we need to do. First, we need to add a Docker file to the repository, so we can build a Docker image out of it. And to do that, we're going to run func init and pass the Docker only. That means that it's going to look at the source repository, and it's going to create a Docker file that fits this project. And this is the Docker file that were created. So it looks at what version of .NET you're using and so on. And the interesting thing is that this is a multi-stage Docker file. So first, this is the image that's used for building the application or building and publishing the Azure function. And the second part is the actual runtime image. So here it's using the Azure Functions /.NET 2.0 base image, and it's just copying the output into that image. So we get a nice small Docker image to use. That's part 1. That means that we have a Docker file, so we could now build and publish this Docker image. And But to do all the things, to build the image, to publish it to a registry, and also to configuring the KEDA scaler, we can use the func Kubernetes command. So this one contains a lot of functionality around the KEDA. And so with one simple command here, I can do all those things. And let's run this, and I will walk you through what it actually does. So what this command now will do is that first it's going to build my Docker image. You can see that it's running it here now. And it's going to tag it depending on the registry that I passed in. So it's building the image. The next step is that it's going to push that image into my Azure Container Registry. Now it actually failed because I haven't authenticated to that registry, so I need to do that first. So I'm just going to log in to my Azure Container Registry. It should be pretty fast. And let's rerun the former command. So the Docker image is already built now, so that step is super fast. And now it's doing a Docker push. And this is also pretty fast because it's a small image. But now at the end here, you can also see that it's creating some additional resources. So now it's deploying the Azure function demo as a Kubernetes deployment, but it also creates this ScaledObject. And these were the files that we created manually before, but now it actually created it automatically. And I can access it by using the kube CLI. So if I do a ScaledObject, I can see that this is the one that we used before for the older processor, but this one was created now, Azure Q function demo. So we can actually take a look at it if you export it as YAML. And so this was created for us automatically. And here you can see that the information that I passed into the command when I ran func Kubernetes deploy, I passed in this information, such as the min replica count, the max replica count, polling interval, and so on. So that's done for me. It also knows which deployment I want to scale. And finally, it configured the triggers. So all these things were done automatically. I didn't have to do really anything here. And let's take a look at the deployments. We should now see an additional deployment here, which is called Azure Q function demo. Again, with 0 replicas, because that's how I configured it. And to see that the scaling works, let's do get deployment and wait and see what happens now. So I have another script that will create a lot of messages into that storage queue. It's a send queue messages here. So I'm going to now just pump a lot of messages into that queue. And once that's started, there you go. Let's go back to the demo here and see immediately now it's scaled up to 1 replica here of my Azure Q function demo. And now it's already up to 4 instances. And each of these instances will now consume messages from that pod and continue to do so as long as we have more than, I think we had 5 messages as the threshold here. So you can see how simple this was to take an existing or a new Azure function, wrap it into a Docker container and deploy it to Kubernetes, and also get the event-based scaling. So, and there's all sorts of event sources and scalers available for various systems. And you can also use this for HTTP triggers, so where you're implementing APIs using Azure functions. The scaling part is a bit different then, because you can't scale exactly in the same way because you don't by default have metrics for it. But you could, for example, use things like Prometheus. So if you're using Prometheus in your Azure functions, that will then be able to expose metrics on how often your API is called and use that metrics. So the Prometheus scaler can then be used to scale your deployments together with KEDA. So you can also scale up your APIs, the number of instances, just like you would if you're deploying this using Azure. But now we can run it in our cluster for various reasons, maybe security reasons, maybe regulations reasons, or for it's actually improving your DevOps workflow to implement everything as standard Kubernetes deployments, which is actually kind of nice. So that was actually my final demo. And just for the last slide, I want to point you to the resources. So Brigade and KEDA are both available on these URLs. And of course, it's a lot of information there and on the corresponding GitHub sites. And the demo code for everything that I showed you today is available on this GitHub link, where you can just play with it. And feel free to contact me over at Twitter. I think I have my Twitter handle here. If you don't want to ask questions now or you're watching this later, just contact me over at Twitter if you have questions around this or you want to discuss more around Brigade and KEDA. I think those are two really cool projects in the ecosystem around Kubernetes, and we're excited to use it for our customers as well. So thank you, and I think I'm hearing Shert here now. Exactly. Yeah, I hope so too.
I muted myself, so now unmuted. Sorry. Um,
And I should just point out that KEDA was quite recently GA'd, so it's a 1.0 and it's production ready. So there's nothing experimental going on here.
Yeah, and I read that also Azure Durable Functions are supported by KEDA now since a couple of days, so that's also really cool.
Exactly. I actually haven't had time to play with that yet, but that was exactly just a week ago, I think. They announced that. So that's another really cool option. So now you can also run durable functions inside your Kubernetes cluster and scale it.
Yeah, so it's really cool technology, and hopefully your session will allow more and more people to start experimenting with this as well. So really thank you for your time, and everyone who was watching also, thanks for watching. We're back next week again. Next week we will host a session in the US, so it will be a bit later for the European people, like around midnight, but in the US it will be 5:30 Eastern Standard Time. We will have a session about Cosmos DB, which is pretty cool. And in 2 weeks, we will host another session again in the European time zone. Then we will have Mark Fussell from Microsoft on the call, who will explain everything about Dapper, where he's the project manager for. So that's also some pretty cool stuff in the pipeline. And so hopefully see you there. Really glad with all the people watching, everyone subscribing to our YouTube channel. We just reached 300 subscribers already after the first week, so we actually reached that yesterday. So if you like this content, subscribe to our YouTube channel and stay up to date for new episodes in the coming weeks. And thanks everyone for watching. So we'll close the stream right now. Thank you again, Jakob, and see you again next week, all of you. Bye-bye.
Sure. Bye-bye.